Yep. All right, well, thanks for coming, guys. So this is a talk on data science as far as just like an introduction goes. And so I'll start off, I'll introduce myself. My name is Wes Eldridge. I'm a software engineer, and I graduated from the University of Alabama in applied economics. And so that is kind of where I got my start into data. And it was more along a financial modeling and time series analysis, but that's kind of, I fell in love with it. And I happened to graduate during the height of the recession, and so there was not many jobs out there for me. And so I ended up falling back onto software engineering because I've been doing that since I was about 14. And so to kind of give you some of the motivations behind why I'm wanting to do this talk and hopefully get into some workshops later on, is that I did fall in love with data, and so I'm trying to make my way back into it and associate myself with a lot of the tooling that's currently in the industry. And so this talk is just going to be kind of brief. I'm hoping to get about 30 minutes out of it. And so we're just going to talk about some of the history of data science and kind of how that has developed over the years. What are some of the roles that data science plays within and using some of the data in products and business and to be able to that landscape and some of the tools and stuff to help you get started. Before there was data science, there was data science. Does anyone know what this guy is right here? It actually came before the LHC. This is the US's version of it. It's the Fermi Lab. And so all this is a really, really big tool to collect data. And so this is where a lot of the data science practices that we have come out of. And so essentially this little tool this big tool will collect hundreds of millions, if not billions of events a second. And then they'll use their big tools, their big server farms to be able to process this. And so this is kind of where big data started at. And so where you actually start getting the term big data popularized, you start seeing it come in about 95, 98, when some of the tools and technologies and the cost around those started to be more approachable by businesses. And that kind of developed over the years, and you started seeing some early business intelligence tools come out that you kind of started seeing SaaS take the forefront, especially within the economics and financial industries. And that kind of starts developing, and then about 2009, 2010, you really start to see the word data science popularized. And so data scientists have pretty much always existed within organizations. It's just now that they've become more cross-functional and are not isolated just to doing analysis. So that kind of brings us up to, what is a data scientist? And so when the part of this popularization of this term comes from two places at one time. So you start to see it on the West Coast, and then it started developing around New York and the East Coast. And so one of the people who really pushed and have helped grow this community is this woman named Hillary Mason. And you'll get some of the slides that you see were actually kind of taken from some of the presentations that she's given in the past. And so she kind of defines just as someone who knows math and stats, who can code, and who can also communicate. And so one of the big functions of a data scientist nowadays is being able to communicate some of the math statistics and being able to engineer those. This kind of gives you this nice data science chart. And so you kind of have this huge, huge group of nerds, and it's just kind of the convalescence of all the nerdness that you can possibly have. And so this leads us into, what do data scientists do? And so when this term started and you actually started seeing people who had data science on their business card, one of the big newspapers started doing did a poll, and they asked data scientists to self-identify. And so you ended up getting essentially 4 big silos of data, what data scientists do. And so you have the data business person, the data programmer, the data visualization person, and the actual research person. And so depending on what your needs are and how your team composition looks, you'll get a variety of skills from a data scientist. And so they concentrate on business, big data, data mining, artificial intelligence and some of the actual statistics and mathematics that goes into building models. And so we can kind of get into how to use data in products and organizations. And so there's always been this really big prevailing mindset to collect all the data all the time. But that only gets you so far. What really makes data powerful, so data by itself is useless. And so until you start applying it and asking the questions peering into the data, it's not actually useful. And so this is when you start talking about it, how this incorporates into your institution or your organization. And so the idea is for you to ask all the questions up front to kind of give you an idea of what data you need to be collecting and how you need to be interacting with that data. The questions, then you can start looking for the data, and in many cases, start building the data in case it doesn't exist. The building the data is something that has been kind of frowned upon just because of the cost of it within a lot of institutions and organizations. And so essentially part of building the data is building the products and services to be able to interact with each other and be able to collect it efficiently. This has been building the data has actually been something that has been prevalent within the scientific community for a long time. That's like actually how they create and build their data. Their models through data collection and building. And so once you have collected the data and you've asked the questions, this is when you can actually start to use it to answer the questions and glean some insight into it. But a data model is not very useful by itself, and so with most of these models, you're able to define a metrics of success. And so when you start looking into like regression and stuff like that, those are like your R-squareds and your error values. And then when you start getting into classification and logistics models, you can do stuff, descent models that allow you to essentially optimize off of that error. But when you start building some really complicated models, especially in some of the classification and logistics regressions, you actually can't provide this metrics of success. And so that's something that you need to be very upfront with when you're starting to present this to people. And so we kind of get into the place to where this is the really important part. So you can do all the data analysis and all the modeling and everything that you want to do, but unless you're able to actually visualize that and be able to tell a story about that, then you're not going to be successful at all. And so one of the big pieces of being a data science is being able to tell a story based off of the questions and the data that you have collected. And so these are kind of the four big areas as far as the process of being able to incorporate data into your organization. But this can only get you so far. From nowadays, when you're building products, you really need to be thinking about how that incorporates into your data strategy. And at Randall, we've played with several data tools to kind of meet our needs. And so if there's something that's not out on the market, which this was taken a few years ago, and this is essentially pretty much any algorithm that you can think exists that we know about, that we have been able to build a product around, it exists out in the market. So a lot of being able to incorporate data into your products and services now is actually kind of finding the tool that kind of fits your need and being able to send data and pull out some of the model from those services. And if you don't, there's this prevailing thought in the industry, if you have big data, just Hadoop. And so there's all this idea that this is the tool, there's this particular tool, and it's really not about picking a particular tool. It's about finding the smart, intelligent people to bring into your organization, and they'll bring the tooling with them to allow you to succeed. And so, Yeah, and so this kind of leads us into the part to how do I actually become a data scientist, or how do I learn how I can interact with the data scientists that if they exist within your organization. And so my big plan is, especially when we start to get into some of the coursework and some of the stuff that we hope to get into later, is start small. So you're going to need to learn how to program, and so it's picking the right programming language that exists and that that you can hire. So some of the big programming languages here, you'll see Python and Java. You'll also see R, which is kind of like an open source statistics library, but it's kind of limited. It doesn't do big data really well. It's more of an academic tool for known data set sizes. And so you start getting into Python, and that's where you're able to do a lot of your analysis. And JavaScript is the de facto front-end visualization tool now. So these are your two big main languages that you'll see in the industry, and they're general purpose languages. So when you're hiring for these particular roles, it makes it really easy. The next is you need to learn about some of the data stores. So we talk about MySQL, and we talk about some of the non-rational relational databases, and you can even get into things that are optimized for really, really big data, like petabytes of data. And it's very important to understand that MySQL or SQL and relational databases are generally not that great for data analysis. They were built for tools that came out of the early, so financial models and stuff, to where you know what the data looks like. But a lot of times when you're actually doing analysis for like user behavior and stuff like that, you'll see that the data is inconsistent there, and it's not, it doesn't follow that structure that SQL tends to put out there for you. And so learning to be able to move data from different data stores is very important. The next we'll go into building some of the mathematical skills. So if you have never had like a statistics course, some of the things that you should look for is being able to do basic regression analysis. So a lot of these tools allow for point and click, and so you can really dive deep really quickly into data and kind of see how it behaves and interacts with each other. And then you'll start getting into some error analysis there to kind of see how the regression model works. And then if you want to make a really, really big step and actually be able to leverage a lot of the tools that you can build yourself, you need to get into linear algebra, because essentially all of this data are just big matrix, and you just multiply and transform. And that is what linear algebra is. And there's a ton of online resources nowadays. And so one of my favorites that I've been kind of using recently is this Kaggle. And so they give you essentially data sets, and they give you challenges, and so you can actually win money on there while learning how to do data science if your model's good enough. So they kind of pitch you up against a bunch of different people. And I don't know if you guys have noticed, but over the last 2 or 3 years, Google, Amazon, and Airbnb have released all of their deep learning and intelligence tools. And so you can go to Udacity and actually get a Google course, like how to use their deep learning, and their particular piece of software is called TensorFlow. And they kind of step you through like the hello world, where you do a very basic classification where you try to discern handwritten numbers, like 1 through 10 or 1 through 9. And then once you kind of get these ideas firmly grasped, where you can go into what to do next. And so from what I'm told, there's a lot of people out there who do data visualization, but the people who are on the mathematical modeling and the statistics side are very, very in the market. And so being able to understand what a logistics regression is, one-hot coding with inside of that for if you're doing kind of categorizing and trying to force an outcome on your model, some decision trees, and then how variables correlate with each other, and some of the multicollinearity inside your model and how those affect it. And then some of the assumptions. So I was talking about the linear regression, and so understanding that your errors need to follow a normal distribution and some of the characteristics behind that. And then we get back into some of the data visualization stuff. And so D3, have you guys heard of D3 before? I know there's a bunch of web people out here. D3 is kind of a low-level visualization tool that allows you to essentially build any type of chart, graph, and anything else in the entire world that you want to be able to visualize. And it's difficult to get into, but if you're a React person, there's a great React library out there that makes some of the basic charting really easy. And then it's really getting your hands dirty. Like I think one of the best ways to get into anything is to actually start digging in and playing with it. And there's all these open data sets that are out there, municipality data sets. And so once you kind of figure that out and start getting into it, start working with some of the municipalities. And there's this really, really cool, cool experiment that this municipality, I think it was in New York, did. They essentially took where all their 911 calls were in the city and then kind of figured out where their ambulance were sitting, and they noticed that they were not sitting in a very optimal spot. And so they went out and asked the ambulance drivers, why are you sitting here? And of course, you know, they're like, there's a Dunkin' Donuts that's open 24/7 and that has a bathroom. And so that like completely makes sense. And so then they were able to work with the ambulance drivers to be able to position themselves in a more optimal position so they could respond to calls quicker. And then it kind of gets back to just telling a story. Once again, like there's a really neat, if you ever noticed in really big cities, you never see logistics people like UPS or FedEx, they never turn left. They always turn right because it's quicker to turn right. And this was one of those big things that came out of data. And so I did this a little bit quicker than I wanted to, as it often happens. So kind of open it up for questions, and that's kind of where I enjoy. So if you guys have any questions about how this into your business or any particular products that you are building, I'd be open to it.
I have a question.
Sure.
So this fits it right into something that I'm working on right now. So the business that we work in, real simple, right? Usually runs on 7-year peak, right?
Sure.
And so we have data going back to the 70s.
Mm-hmm.
And so I'm trying to fit that to almost like a Fibonacci type progression, treat it like a stock, right? Assuming that it's going to peak and valley.
Well, like if it has like some, oh yeah. So it's kind of, you're asking about being able to model seasonality within data, but your seasonality is over a 7-year period. And so you would essentially kind of model it the same way that you would do like a short term, like if you had sales figures that had some seasonal trends to it. And so most of the time that's a pretty simple regression. And so you have a linear component to it, and then you have your seasonal trends to it. It will be how those seasonal, like if they're, what the variance between the seasons are, it would just be one of those things you would have to look at. But a very simple linear seasonal regression could be really, really beneficial in that period for that type of data.
Can you talk about, I guess maybe more on maybe the buy-in side with some of these tools and within an organization that may not be as quick to adopt and is interested in trying the new hot thing, how you approach that and how you talk about the value that some of these type things can bring to the organization?
Sure. Like if you start using a secondary tool, like a third-party tool, when you build stuff in house, you're able to kind of define those success metrics. But like with any third-party tool, you're going to have to be able to derive your ROI out of that, and so it will kind of depend on some of the metrics that they provide you. It also comes down back to like some of the questions that you want to ask. You know, it's hard to talk about any because it's such a wide scope, but we're working on in our business. I can't really come up with anything off the top. So doing some of the planning around fulfillment of invoices, and so being able to kind of look at some of that in the aggregate, and then be able to essentially, the value would be, it's like we'd only be in big trouble like if we did planning wrong or something like that. And so being able to ensure that, so we're talking some ads. So, you know, we do a lot of ads and stuff at Randall, and so being able to not put ads of your competitors on your, and so those are kind of some use cases that where you can see, and it will just be some of the tools that you use that kind of will be, it will vary based off the tooling that you use.
Let's have a question from Rachel in our YouTube chat. So she says, what are your thoughts on data science in regards to companies framing or collecting information about people in order to sell data, ads, etc.?
Yeah, there's this idea, like, you know, everyone is collecting data, and so you kind of have to ask yourself as an organization, what is the worst thing that I could possibly do with this data? And so that kind of gives you a reference frame as to, you know, what could be the actual social impact of this data. And so you kind of have to make your decision at the organizational level, whether or not you're going to be good with it or bad with it.
Yes, she actually points out that I misread her question. And actually, she's interested in whether or not companies are farming or collecting information about people in order to sell ads.
A lot of people are, for sure. Like
not framing, but farming.
Definitely. The cookie trail is something that's really, really big. And so with the invention of some of the analytics, the way that kind of worked early on is that when you as an advertiser would have a pixel on somebody's website, and then they would also have a counter pixel. And so there essentially you would be able to not glean too much information about a particular user, but you would be able to see where that user navigated to in your site. So that's been a practice that has been around for a long, long time. And with just like, you know, I can speak personally, like as far as like my business goes, we use a bunch of data tools, and we collect a bunch of data on users' behavior and stuff. And as part of our actual product development cycle, like that's how we validate a lot of our value and which part of our systems are actually being used the most. It would be like some of the third-party leaching that I would be worried about. So like when you do engage with some of these third-party services that collect data on your behalf, like what is their exposure and what is your exposure through them? Yeah?
So
yeah.
I have been working on a data project at work.
Yeah.
Trying to pull in advertising data across multiple different platforms with the goal of identifying a particular client's performance-related data, whether or not the campaign is getting a certain number of impressions or a certain number of clicks, and we'll use multiple different products.
Yeah.
We've been deploying these campaigns that have no standard. So when we try to connect the data together, once we get it into spreadsheets or get it into databases, there's no common data point because no one asked for a client name.
Yep.
There seems to be a lot, and this has been my personal experience, there seems to be a lot of research necessary to understand the data before you ever start charting it.
Yeah, definitely. Like that's what we were talking about. Just collecting data doesn't really get you that far. It's being able to understand it. And so we've talked in the past about being able to warehouse a lot of this data and kind of pushing stuff into it. There's a really great company out there called Segment, and they kind of specialize in data warehousing and being able to do segmentations like within your data. And then also being able to connect those two together. It's a challenge for everyone, especially when you have multiple data streams that you don't actually control and you're kind of pulling in. And if you're using a third-party tool like we are, it's just one of the challenges that come with it. There are some tools, like some of the tools that we use, like when a lead comes in, like it automatically goes through and finds all of the social information that they could particularly have based off of the information that they gave us. And so that gives us a lot of information right up front. And so maybe, you could possibly try looking into some of those tools that kind of aggregate that data for you instead of having to connect it. You still come into the problem when you're, and in our case, trying to build tooling around being able to provide ROI to our clients and exposing that to the clients. And that's always going to be a challenge.
So where do you feel like you are in your personal goal to become a data scientist? Where do you feel like you are, let's say percentage-wise?
That's like saying how much of a percentage are you of an engineer or developer? It's kind of like a lifelong thing.
So like, let's rephrase. If you try, how many hours might you try to accumulate that you might have put into this?
So I got a lot of the basics and stuff in college. Like I taught Stats 260 for a long time, or TA'd Stats 260. I only got to teach it one time, but so I had a lot of that effort in college, and so a lot of it is just kind of reassociating myself with the tools, and so I've been putting a lot of effort more into the machine learning. So this presentation, if you saw the little guy in the bottom, it's through one of my companies called Rebellious Labs, and so we're working on some home automation stuff, and so I've been playing with a tool called Thanos, and it essentially takes like an off-the-shelf kind of generic Python deep learning algorithm, and then you can also run it alongside TensorFlow. So a lot of these big tools, they are kind of specialized in certain areas, and so being able to run both of them, and because one's going to be really good for large data sets, and the other one's going to be a little bit smaller, or a little bit better for smaller data sets, and so it's kind of figuring out. We were talking about some of the error analysis and kind of how they handle that, and so when you're doing deep learning on kind of smaller data sets, you'll get into this idea of cross-validation, and some of the tooling works better with cross-validation, where some of them you need kind of a reserved data set to be able to train on, or to make sure that your model. So essentially, you train your model on some of your data, and you can always model your data that you have is good, really, really well, but you're not really worried about the data that you're training on. You're worried about the data that you're feeding into it. And so being able to take aside some of that data, train your model, see how it interacts with that data, and so you kind of have this iterative approach as you optimize your model. And so I'm kind of working through the nuances of that right now.
For a new data scientist or something,
Yep.
do you have any tips or advice with regards to documentation or testing? It's normal because
Yeah.
it seems that data science is always sold as this thing that the AI will solve all the problems.
Is
no one understands what the algorithm does.
Yeah. Yeah, so he was asking if I got it right, like some good steps into getting into data science.
But also for documentation.
For documentation in person. So there's this. Yeah, so there's this little bit.ly link right here. And I'll share these slides afterwards, but I'll put all the resources and stuff that I've been gathering over the past couple of years there, and so you can kind of see some of the tools. But there's this overwhelming consensus that academia is not actually doing what we need to as far as being able to provide qualified data scientists in the market. And so there's this really cool project that some people started, if I know which way to go. It's called the Open Data Source Data Science Masters, and so they're kind of starting to. They're the guys who kind of wrote this and who've been working on this have actually been trying to solve some of the problems that just exist within the data science. So like in the programming industry, we have some very set standards as far as like how we develop and like how folder structure looks like, and like what, how a project looks like when it's actually on the hard drive. And so some of these guys are doing some of that, and so being able to provide you with the tooling so any person, whether they're a developer or a data scientist, can jump into a project and be able to pick it up and see what's happening. And so they go through a lot of, this will give you some of the insights into actually how to become a data scientist, and so they'll talk about some of the internet is your oyster. So they go over, they give you some video courses to look at and do some other things. And the big thing is just getting into it and doing it. So this is as far as like finding documentation on how you become a data scientist. This is a huge, huge, huge resource. Like I leverage it quite a bit. And there's, we can talk afterwards and I can show you some other things, but there's plenty of stuff out there. It's just kind of finding it and trimming out the fat and the crappy, the crappy references. But I've done quite a bit of that. So I'll share that on that bit.ly link at the end of the night.
What are some other programming languages you recommend? Like I really only know how to do like SQL queries. I don't know how to do anything. C++ or Python for the most part.
You're not actually going to see C++ in data science that much. Like when you start getting into like the scientific research side of stuff, you'll start getting into C and C++ because of just sheer enormity of the data that you're dealing with. But a lot of times in the industry, you're going to see Python for the most part. You can do some stuff in JavaScript and PHP, but once you start trying to scale, a lot of the tooling is already in Python, and so Python does some really cool things where they're actually you can actually drop some of your processing off onto like GPUs and stuff like that, and so it's an interpreted language, so it kind of runs in a sandbox. So you're actually able to drop some of that out of the sandbox. So you can receive some of those efficiencies that you would typically see in some of like your C and your C++ languages, where you're closer to hardware, but Python's I would say would be, if you're wanting to get into it, would be your best bet. It's straightforward, really easy language. It's object oriented, so if you've been in that realm, like you just don't have semicolons and brackets and stuff. It's all done off of like tabs and spaces, yeah. But Python for sure. Thank you guys.